All right, guys, let's do our last foldable for chapter 3. So that's something to celebrate. And I'm just going to use different color highlighters here. So in this one, we have 12 boxes, and it just says, are they parallel, perpendicular, or neither? So just to review, if they are parallel, we know they have the same slope. Okay, if they are perpendicular, we know they have opposite reciprocal slopes. And of course, if they neither, they have something other than either same or opposite reciprocal. And we're talking about slope when we have an equation in y equals mx plus b form. The slope is our m. Okay, so that's all something that we need to remember. So let's just say if they're parallel, they're yellow. Okay, now let's look at this. Are there any that really stand out that we can look at and say for sure, oh yes, those are parallel? What draws my attention is this box right here. Notice y equals 2x plus 1, y equals 2x minus 7. Well, remember the slope is 2 and the slope is 2, so same slope. So this would be parallel. Okay. Let's look at any of the other ones. Are any of them like super duper obvious that they're parallel? Not really. So let's go to perpendicular. Now some of these we're going to have to work for, and I'll show you how to do that. Okay, so we're going to say if they're perpendicular, they're purple. Now I want you to look through here real quick and try to find a minimum of 2 that are perpendicular. I'm going to give you a minute, but a minimum of 2 of these should stand out. All right. You should have known that -3 and +1/3, remember this -3 is the same thing as -3/1. So that would be opposite reciprocals. So I'm going to highlight this purple. And then it may not be obvious, but on this one here, when it says -x, think of a -1 here. And think of a -1 as -1/1. And then here, it's just a positive x, so it'd just be 1x. Well, 1 is the same thing as 1/1. These, -1/1 and 1/1, those are opposite reciprocals as well, so that should be another one. There's one more that should be obvious, and that's right here. So +4/3 and then -3/4, those are opposite reciprocals, so we'll do that as well. Okay. If I look at this one right here, so I have a coordinate grid, okay? X equals 5, if you recall from Algebra 1, is a line that goes up and down like this that passes through 5 right here, okay? And then y equals 7 would go right here. So wouldn't these, this is a vertical and a horizontal line, wouldn't these be perpendicular as well? So I'm going to go ahead and mark that in like that. All right, now we do have some that are a little bit tougher, okay, that aren't as obvious. So I'm going to look at this square right here. Okay, so let's look at this square a little closer. So y equals -3/4 x plus 3. That's pretty obvious. But this 3x, oh, let me move it over some. I'm going to run out of room here. This 3x plus 4y equals 3 isn't quite as obvious. Okay, so what I have to do is I have to rearrange this equation so that it's in y equals mx plus b form. So the first thing I'm going to do is subtract 3x from both sides. So I get 4y equals -3x plus 3. And then divide by 4, so I divide the whole thing by 4. I get y equals -3x/4 is -3/4 x plus 3/4. Okay, so this equation has a slope of -3/4. Okay, well if I look, the equation above it has a slope of -3/4 as well, so those are parallel. So I'm going to go back. Yellow is my parallel, so I'm going to go back and do those parallel. Okay. So do the same thing with all of these. I want you to go through, try to do these on your own. If they're not written in y equals mx plus b form, change them to y equals mx plus b form before you decide if they're parallel or perpendicular. And then I will come back and show you what I got so you can compare it with what you got. All right, guys, after I worked all these out, put them in y equals mx plus b form, this is what I came up with. Notice I used blue to highlight neither parallel nor perpendicular. So compare yourself to mine and bring to me any questions. But that concludes all the foldables for chapter 3.